Hi there. Let me take a few minutes and take you through how to create what's called a box and whisker plot. So I suppose technically this is what's called a modified box and whisker plot because we're also going to test for the presence of outliers, but we will do that second. Let's just make the plot first. So these data represent the prediction differences, the differences between the predicted weather forecasted high and the actual high for 30 days in September. So this -8, for instance, this -8 means that the prediction was 8 degrees below what actually the high was. This means that the prediction was 2 degrees below what the actual high was. So all of these zeros mean that the prediction and the actual high temperature for that day were correct. So positive values, for instance, these 4 here represent that the prediction was 4 units, 4 degrees above what the actual high temperature was. So another way to graph data besides doing a histogram or a stem and leaf plot or a dot plot is to do what's called a box and whisker plot. A box and whisker plot is a very convenient type of a plot because it lets us visualize some of the variability. So to start, you need to create what's called a 5-number summary. So first you want to find the median. There are 30 values here. There are 15 in the top row. There are 15 in the bottom row. So literally the median is in between this observation here. This is observation number 15 and observation number 16. So notice I've already put them in order. So the median would be the average of this 0 and this 0. So clearly the median, which would be right here, the median is 0. A difference of 0. So now notice the median also breaks the data up into the lower 50% and the upper 50%. So these are the lower 50%. These values are in the upper 50%. The median splits this into 2 equal parts. So let's look at the lower 50%. There are 15 data values there. We can find the middle of the lower 50%. That would be observation number 8. 1, 2, 3, 4, 5, 6, 7, 8. Here is observation number 8. So there are 7 below it, there are 7 above it. So this observation is the middle or the median of the lower 50%. We label it Q1. Q1 stands for the first quartile. Q-U-A-R-T-I-L-E. Quartile. Now the reason it's called that is because we have broken the lower 50% into 2 quarters. So here, this is the lowest 25% of the data, right here. Then here, we have the second lowest 25% of the data. So notice we can also do that with the upper 50% of the data. We can find the middle value here. Again, it will be the 8th value, 1, 2, 3, 4, 5, 6, 7, 8. Here it is. This is called Q3, the third quartile. And again, notice it takes the upper 50% of the data and breaks it into quarters. So here is 25% of the data once again. And here is the last 25% of the data. So along then with the minimum value, which is the -8, there's the minimum, and the maximum value here of 6, we have the 5-number summary. So literally these 5 numbers break the data up into quarters. So the 5-number summary, if we write it out, so first of all you have the minimum, which is at -8. Then you have Q1, which is at -1. We have the median, which is at 0. We have Q3, which is at 2. And then we have the maximum, which is at 6. So these 5 numbers are what's called the 5-number summary, and we can use them to make a graph of these data. So I'm going to use it, I'm going to do this part in pencil. So we start with the median. The median is at 0. So the first thing we need to do is label our graph. So I'm going to start down here at -10. Our data run from -8 to 6. So I'll go -10, -8. Oh, actually, you know what? I've got plenty of boxes here. We'll make each box 1 unit. -10, -9, -8, -7, -6, -4, -2, 0, 2, 4, 6, 8, 10. There we go. So now what's interesting here is you don't have to label the y-axis. What this graph is going to do is literally show us how the data values are spread out between the minimum and the maximum. So let's start with the median of 0. So I'm going to put a bar here at 0. And then I'm also going to put a bar at -1 and at 2. Those are the locations of Q1 and Q3. So here is Q1 at -1. Here is Q3 at 2. And I'm going to form a box out of them. That's why this is called a box and whisker plot. So literally, here is Q1. I can see it. Here is the median. And here is Q3. Now, notice what this does. This is actually the middle 50% of the data. From Q1 to the median, that encompasses all of these values right here. This gives us a picture of how spread out that quarter of the data is. Here's the next quarter of the data from the median to Q3. This quarter of the data, it's a little more spread out than this quarter of the data. But that's a total of 50% of the data. And in particular, it's the middle 50% of the data. So the difference from 2 to -1, that difference is 3. That's called the interquartile range. And it is another measure of spread. Let me write that out. In addition to the full range or the standard deviation, another way that we can describe spread is with what's called the interquartile range. INTERQUARTILE, interquartile range. So literally what that is, it is the difference between Q3 and Q1. So literally if you subtract them, so Q3 is at 2, Q1 is at -1, so 2 minus -1 is 3. So literally what that does is it gives me the range of the middle 50% of the data, the range, if you will, of what I call the meat of the data. So this is the range of the middle 50%. So this is called the interquartile range. Sometimes we abbreviate it as IQR. So I'm going to list that here as 3. It's not technically part of the 5-number summary. The 5-number summary includes the minimum, Q1, the median, Q3, and the maximum. But it gives us another measure of spread, how spread out the middle 50% of the data are. And we can calculate it very simply just by looking at the 5-number summary. So this is the middle 50% of the data. Let's also graph then the rest of the data. And now we'll see why it's called a box and whisker plot. The maximum is up at 6. So I'm going to put a point at 6, I'll put a little dot there, and then literally from Q3 up to the maximum, I'm going to draw a little line segment. We call that a whisker. So here's the maximum. And then notice the minimum is way down here at -8. So I'm going to put a dot down here at -8, and again, I'm going to draw a whisker all the way up to Q1. So this is the minimum. So notice what this gives us. This gives you a picture of the 5-number summary. So here is the minimum, here is Q1, here is the median, here is Q3, and here is the maximum. So it gives us a visualization of how spread out the data are. So literally, down here, this is the lowest 25% of the data in this whisker. Here, between Q1 and the median, is another 25%. Here is another 25% between the median and Q3. And then between Q3 and the maximum, there is the upper 25%. So literally, we have broken the data up visually into quarters. So you can see that this is the 25% that is most closely packed together. Between the median and Q3, it's a little more stretched out. This whisker is even more stretched out. And of course, this is the most stretched out whisker of all, if you will. You can see the variability. So I would suggest, though, that these data have some outliers. So if you take a look at the next video, we're going to look at how do you determine mathematically whether or not you have an outlier. How do you plot it then?